numbers have been the first things we learn about in mathematics. We learn to count, like 1, 2, 3, and so on. But as mathematics becomes more and more complex, we look towards fractions to give meanings to those numbers with infinitely long decimals. This ushers in the existence of rational numbers. In layman's terms, these are numbers able to be expressed as ratios or fractions, such as 3/7.
However, with this new and fundamental type of number came an unexplainable phenomenon: irrational numbers, namely roots. These numbers have intrigued mathematicians for millennia, so we can't compute the exact value of these numbers. But what we can do is accurately plot them on a number line.
In order to plot the square roots of the integers on a number line, we use the existing number line as the x-axis of a Cartesian plane and point 0 as the origin. From there, we draw a line of length 1 perpendicular to point 1 on the x-axis as shown. Then, we draw a line from the origin to the top of the line we have just created. The length of this line, by Pythagoras, is root of 1 squared plus 1 squared, which is root 2, the length of the diagonal of a square of width 1. Using the line of root 2 as the radius, we are able to draw an arc that meets at root 2 on the number line, as a circle is equidistant to any point on the circumference from its center.
Now, how do we continue to construct roots 3, 4, and 5? Well, we have our original root 2 line, which we can now use as a base to draw a perpendicular line of length 1 from. Connect that point at the end of this new line to the origin, and we have a line equal to the root of root 2 squared plus 1 squared, which is root 3. Once again, we will make an arc centered from the origin to this point so as to plot it on the line.
You may be able to guess what happens next, but if you don't, we then extrude another line of length 1 from the root 3 line like this, and join the endpoint to the origin again, to get a line that has the length of the square root of root 3 squared plus 1 squared. This gives us a line of root 4, or its simplified form of 2. We continue like this up to infinity, or root 17 in our case.
The ancient Greek mathematicians would have had to use this method to create roots, as they only had the compass and the straight edges to construct magnitudes to be used in their math. They could also have used a method using semicircles, but that's for a later time. Thanks for watching, guys. Kevin and I took a long time to make and edit this, so yeah, bye.